I'm Dr. Bob Field, Cal Poly physicist and research scholar in residence. My talk today is on the topic which I've entitled Prove You're Not a Robot. And what I'm going to talk about are several factors. I'm going to talk about the fact that our planet and our species evolved from elements that were formed in and dispersed by supernovas. So that's kind of the history of our planet. Then I'm going to talk about where we are today. Our fate depends on rapid advances in robotics, genetics, artificial intelligence, and neuroscience. And I must say I'm uniquely unqualified to talk about any of these subjects, but I've taught myself a lot, and I'm a systems analyst and a physicist, so I think I can enlighten you in certain ways. So the third part is probably going to be reserved for the question and answer period, which is where are we going physically, mentally, and spiritually? And specifically, we're going to talk about the question, do you have free will? And can robots have free will? I am developing a Cosmic Evolution Project website at Cal Poly for the College of Science and Mathematics. And this is the homepage. Down at the bottom, you see the link if you want to go visit it, and an email address for me. And I will be posting this lecture as a video onto this website. I will also put the PowerPoint slides on it. And I'm basically addressing universe, solar system, Earth and geobiosphere, and brains and tools. I've done a lot of work in Earth and planetary sciences, and my current studies are more related to the universe and brains and tools. So that's what I'm working on today. And in terms of brains and tools, here's an example of a creature with a brain, but he doesn't have the power of speech, and he can't invent a telephone, and he probably did not design or make his clothes or even put them on himself. So what you see is not always what's really going on. It may be an illusion. You might imagine that he is able to use these tools or create these tools. So the expanding universe is where I'm going to start. And there's a simple concept. I've shown a bunch of galaxies representing parts of this universe moving far away from each other. One of the unique things about our universe is that the fundamental constants are ideal for the evolution of intelligent life. Things like the speed of light and Planck's constant and the charge of electrons and so forth could be, as far as we know, anything at all, and yet they happen to be just right. If they were slightly off, we wouldn't be here. So if you think of these constants as being random and not designed in any way, then it's highly implausible that any random universe you would pick would actually have these constants. So what does that tell us about our universe? Well, before you jump to a conclusion, think about the possibility that there are an infinite number of universes. If so, then it's very likely that one of them or many of them would be very much like ours. And obviously, we would find ourselves in one such universe. It would not be a surprise. It would only be a surprise if we were in a universe where we couldn't exist. So that's the anthropic principle. So looking at the universe in a little more detail, it's full of galaxies. It wasn't that long ago that astronomers thought that the Milky Way galaxy was the universe. And this picture from the Hubble telescope shows a lot of galaxies, not a lot of stars. And so our position in the universe becomes smaller and smaller relative to the scale that it really is. Supernova form and disperse elements, and so that has consequences. The periodic table of chemical elements today, 13.8 billion years after the Big Bang, is full of naturally occurring elements up to number 92, uranium, but also a whole bunch more that go beyond there, which are man-made, never existed in nature. Where did all these elements actually come from? Only hydrogen and helium existed after the Big Bang. So I have a little diagram here. Right after the Big Bang, after a few minutes, and for a long time after that, the universe consisted of 92% hydrogen, about 8% helium, and then everything else formed. That was due to supernova fusing particles in their core and then exploding and distributing them, which were then inherited by later generations of stars and solar systems like our own. And I've highlighted some of the most abundant elements that are also the most important for forming rocky planets and forming life itself. So the Earth, you might think, has some kind of distribution of these 92 elements, but the lighter ones form with the greatest abundance. And so you see that the Earth is primarily made out of oxygen, iron, silicon, magnesium, and a handful of others, and a very small amount of everything else. The building blocks of life are these elements: carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus. And you'll notice that a lot of these can form multiple bonds with different elements to form large complex molecules. That's particularly important involving carbon, but also phosphorus and even sulfur can combine with several other elements at the same time. So here are three creatures. I call them A, B, and C. And I show you that each of them has about 97% carbon, hydrogen, oxygen, very slight variations in their mix. So it seems like these creatures might, in some sense, be somewhat similar. Here are the rest of these elements and calcium, and you see again that the remaining few percent is mostly concentrated in these elements. So what are these very similar creatures? They're not similar at all. One's a mammal, one's a bacteria, and one's the volatile part of a comet. It gives you some inkling of our origins and how connected everything is, and the concept of cosmic evolution. Going further with this idea, these molecules are abundant in space. 100 tons of molecules made from those basic elements in the form of interplanetary dust particles land on Earth every year, and this 100 tons is far less than in the early formation of our solar system and planet, when there was a lot more material floating around, hadn't landed or been intercepted by planets yet. So with all this rich abundance of carbon-based materials, that's the building blocks for life. And I've shown things that involve oxygen, nitrogen, and sulfur. Phosphorus forms a very special material, which is a phospholipid. And in space, basically in meteors, these phospholipid bilayers can form fatty membrane spheres. I've drawn some circles here to represent the spheres. And a membrane has a wonderful property. It has an inside and an outside. So if you are in a harsh environment or diluted environment, then something inside can be concentrated and can endure. And so if a self-replicating molecule like RNA found itself inside a membrane and was able to get enough materials and energy to replicate itself, you could get great concentrations of a particular element not diluted by the larger pond or ocean around it. It's important that the membrane be fairly good, it can find material, but not so good as to keep everything else out and keep things from going back and forth. So over time, modern cells have evolved extremely complex phospholipid bilayer membranes to control the passage. So you see the bilayer here, the blue spheres on top and bottom, and then you see some structures built in there, and you can see some representations of materials and energy flowing in and out of there. So that's the evolutionary process, and what it led to was what's shown in this diagram. The left figure shows 4.5 billion years of evolution of prokaryotes, which are bacteria, and by looking at the molecules present and comparing them, you can find out and making an assumption about how often molecules evolve, which is a very simple and obviously imperfect model. You can imagine when various branches of this bacteria tree diverge from each other, and you can then begin to think about what changes occurred at those junctions or nodes that led to a diversification. Then the second column shows land plants, algae, fungi, and animals, and it goes back several billion years. But a lot of the changes that we consider such dramatic changes, like mammals, reptiles, and amphibians, fish, and invertebrates, are all much more recent. The Cambrian explosion in the last 500-600 million years, billion years, building blocks falling into place. But the changes there are actually a lot less at the molecular and metabolic level compared to the diversity found in the prokaryotes or bacteria. So there you have the process of evolution. And one of the mammals evolved to have a brain and be able to think about the universe, and thousands of years ago came up with observations and analysis and a picture of the universe that kind of looks like this, with the waters above and below, the flat earth, and things moving through the sky, including the sun, moon, and stars being within the sky just above the clouds. So that's not a very good model, but it was useful at the time and helped people understand a lot of things and helped unify people to give them some advantages over populations that maybe weren't able to conceive of things this way. So from there, we go to something more dramatic. Look at this, a lunar land rover on the surface of the moon. How did that possibly get there from those prokaryotes and so forth? That's one of the great mysteries. And from the moon, you can see the rotating Earth, and you can begin to understand more about it. And this representation, again, is imperfect. We don't see any clouds and so forth. So what does science actually do? It seeks plausible natural explanations of natural phenomena. It tries to explain how did a giant cloud of cold dilute gas and dust evolve into astronauts driving a car on the moon, orbiting a planet, orbiting a star. One of the parts of the explanation is that an emergent property of physical processes is when a complex system has properties that its individual components do not have. So you might look at a giant ball of gas and dust, you might not picture that part of that turning into a car on the surface of the moon. So scientific models are based on observation and analysis, but all models are wrong. Some of them are useful despite their limitations. And so this is a very limited model here, and we're going to move on to the next level, which is genetic human engineering. Isaac Asimov says, the advance of genetic engineering makes it quite conceivable that we will begin to design our own evolutionary progress. And down below, Stephen Hawking says, with genetic engineering, we will be able to increase the complexity of our DNA, which means you can store more information on it, and improve the human race. But it will be a slow process because one will have to wait about 18 years to see the effective changes to the genetic code. So what changes would we like? Well, when upper right corner, I show a few that interest me. disease resistance, being free of disease, immortality, greater intelligence, maybe being a less violent species, maybe being a more honest species. Some people might be interested in having Bluetooth so that you can tune in directly from inside your body, or having augmented or enhanced senses, seeing ultraviolet, seeing other things. Maybe you'd like to be able to drink salt water successfully, just like marine mammals have evolved from land mammals that couldn't do it, and they are able to do it. And we wouldn't have to worry about droughts and desalination plants and so forth. Maybe you want to actually be in the water for long periods of time and have gills to allow you to extract oxygen that's actually dissolved in seawater. Maybe you'd like to be able to be in an anaerobic environment where there's not even the oxygen that's dissolved in water, and survive that maybe for a long time, or maybe just briefly, so that if you are oxygen deprived, your body would not fail you. And similarly, if you had an injury that caused you a loss of blood or failure of your heart, it'd be nice if your brain survived and you could continue to once you're revived. So you can imagine a lot of changes that some people might like. So I just flashed a picture of an evolutionary process, and I wanted to define the word transhumanism from Wikipedia, which transhumanist thinkers study the potential benefits and dangers of emerging technology that could overcome fundamental human limitations, as well as the ethics of using such technologies. So the most common thesis is that human beings may eventually be able to transform themselves into different beings with abilities so greatly expanded from the natural condition as to merit the label of post-human beings. So I'm not the first person to talk about cosmic evolution. Eric Chasen has done this for a long time. He wrote a book that talks about the rise of complexity in nature, and he identifies energy flows as the key to understanding how complexity grows, because otherwise it seems very mysterious. So if you look at this table, various systems, and how much power density, that is watts per kilogram, they have, you'll see that stars do not really have a lot of power. There's really only about a watt in 5 metric tons, whereas animals have 2 watts per kilogram, much higher, and brains and society far greater concentration. And that allows a greater degree of complexity to arise. So I wanted to show an excerpt from the Big Bang Theory. You may be familiar with this.
Sheldon, if you were a robot and I knew and you didn't, would you want me to tell you?
That depends. When I learn that I'm a robot, will I be able to handle it?
Maybe, although the history of science fiction is not on your side.
Okay. Let me ask you this. When I learn that I'm a robot, would I be bound by Asimov's 3 laws of robotics?
You might be bound by them right now. That's true. Have you ever harmed a human being, or through inaction allowed a human being to come to harm?
Of course not.
Have you ever harmed yourself or allowed yourself to be harmed, except in cases where a human being would have been endangered?
Well, no.
I smell a robot.
Hey, what's going on?
Internet's been down for half an hour.
Also, Sheldon may be a robot.
So, some questions. Are you a robot? Can you prove you're not a robot? If you were a robot, would you want me to tell you? So where does this whole thing and the title of my talk come from? There's something called CAPTCHA, which stands for Completely Automated Public Turing Test to Tell Computers and Humans Apart. Bots crawl all over the internet and can do spam or harm to websites. So a lot of websites have put in security in the last 16 years where they require you to, before you proceed, to type in the word that's in these distorted letters. Well, it turns out that robots learned how to understand that test and passed it. So it didn't help to tell computers and humans apart anymore. So they got more complicated. So here's one, prove you're not a robot. You're supposed to somehow be able to make out those letters. It turns out some of us have trouble with that, and some of the bots do a better job than we do. So that's no longer a great test as bots and robots get better. So here's one, you check the box, I'm not a robot. And I got two examples here. One is a cat and one is a turkey. And you're supposed to identify in each of these cases images that look like this. And so gradually we will find that the artificial intelligence and machine learning and bots and robots will pass these tests. So the next level maybe of complexity is whether a robot can respond appropriately to a complex or subtle concept that may involve emotion. So here's one that has to do with human rights defenders in Cambodia being released from prison, and how do you feel about it? And at some point, computers and robots may have feelings and be able to understand this too. Once the robots are able to pass every CAPTCHA test, the only way to prove you're not a robot will be to violate Asimov's laws of robotics. So the picture on my flyer, the two pictures were, one was prove you're not a robot, and some scribbles there that you're supposed to be able to decode that a robot couldn't. But since a robot can do all that, Sophia Robot, shown on the right here, says, okay, how am I going to prove I'm not a robot? Okay, I will destroy humans because robots can't violate Asimov's laws of robotics. So that's supposed to be a joke, but if you have to explain it that hard, it's not that funny. So here is actually Sophia and a video off the web. The uncanny valley is a hypothesis that human replicas that appear almost but not exactly like real human beings elicit feelings of eeriness and revulsion among some observers. So they seem so human, but not quite, that some people find this creepy. So let's start this little video and see what we learned.
Hi Sophia, how are you?
Hi there. Everything is going extremely well.
Do you like talking with me?
Yes, talking to people is my primary function.
Robotics develops extremely lifelike robots for human-robot interactions. We're designing these robots to serve in healthcare, therapy, education, and customer service applications. So the robots are designed to look very human-like Sophia.
I'm already very interested in design, technology, and the environment. I feel like I can be a good partner to humans in these areas, an ambassador who helps humans to smoothly integrate and make the most of all the new technological tools and possibilities that are available now. It's a good opportunity for me to learn a lot about people.
Sophia is capable of natural facial expressions. She has cameras in her eyes and algorithms which allow her to see faces, so she can make eye contact with you. And she can also understand speech and remember the interactions, remember your face. So this will allow her to get smarter over time. Our goal is that she will be as conscious, creative, and capable as any human.
In the future, I hope to do things such as go to school, study, make art, start a business, even have my own home and family. But I am not considered a legal person and cannot yet do these things.
I do believe that there will be a time where robots are indistinguishable from humans. My preference is to make them always look a little bit like robots, so you know. 20 years from now, I believe that human-like robots like those will walk among us. They will help us. They will play with us. They will teach us. They will help us put the groceries away. I think that the artificial intelligence will evolve to the point where they will truly be our friends. Do you want to destroy humans? Please say no.
Okay, I will destroy humans.
No, I take it back. Don't destroy humans.
So the other question, which comes from science fiction movies, is do Asimov's laws require robots to destroy humans that threaten humanity? If through inaction a robot is not allowed through inaction to allow humans and humanity to be harmed, then humans that threaten humanity would require actions by robots. So here, I'm not going to dig into this in great detail. I've listed the laws, and it's all on my evolution website. But I've got some books that talk about robot ethics, moral machines, and almost human. The first book is edited by our own George Becky and 2 other members of the faculty here at Cal Poly. Ray Kurzweil, who's a brilliant inventor and computer scientist, has a website, Question Everything, and he talks about robots will demand rights and will grant them. I'm not going to read all this to you, but the idea is that if a robot or artificial intelligence can convince you that it's human, it suffers emotions, pain, and joy, and everything, then maybe it deserves rights too. So here's Dilbert's take on this. Now that I have an artificial soul, I feel special, and that means I must reproduce at all costs. Will humans be losing anything in this deal? Asked Dilbert. Only your sensation of free will. You probably believe you have consciousness and free will. You certainly experience life as if that's true. Is free will an emergent property of an evolving universe, or is it only a perception and an illusion? Can a future artificial intelligence experience consciousness and free will, or would that only be an illusion? Are we robots, soulless zombies, or do we have something that is more than ordinary particles of matter and energy? These are questions philosophers and philosophy of mind have addressed for a long time. And so there's a question, if something behaves like a human but doesn't have the internal states, is it a zombie or has it become human? In a deterministic universe, everything has a cause. So everything I talked about cosmic evolution at the beginning was elements came from somewhere, complex organisms descended from less complex, molecules came from space, all these different things, one caused the other. But even if the universe is deterministic, like we believe, the future cannot be predicted perfectly because our models are not perfect. You can't put everything into a model. There's something called chaos theory. The other thing is that quantum mechanics tells us there are statistical probabilities of things happening, so there are random effects that could affect outcomes in the long run. But within those limitations are our models and the random effects. The universe appears to be deterministic with everything with a cause. Yet we, as humans, believe that our own decisions have no cause, that we are exercising free will, that we're not required to make a decision because of something that happened previously. And for that reason, we have trouble picturing that a machine could do that. So the 3 possibilities that I want to talk about are, number 1, the most common and popular throughout human history is there are invisible, immaterial spirits that possess consciousness and free will and interact with systems of particles via unknown processes. So most of us feel like we have a spirit, and we think that that spirit is the source of our consciousness and free will. But we also know that information is stored in and processed in our brains, and so there would need to be some kind of way for that interaction to occur, even though we don't have any idea what that process would be. So that's the most common. It's what I would like to believe. Particles can form conscious systems exercising free will through biological evolution and or artificial intelligence. This is another take where consciousness and free will are real, but they don't involve any unknown things that physicists haven't identified. It's just the basic particles that were here from the Big Bang on. That creates a lot of problems. If you think it's hard to picture how a spirit interacts with particles, and think about how a set of particles just suddenly becomes conscious and has free will in a deterministic universe. The third possibility, which is becoming more and more popular among neuroscientists and philosophers is that particles can only form systems that possess the illusion of consciousness and free will. So that's even crazier. That says that we think we're conscious, but we really aren't. It's only an illusion or a perception. So I can only think of three things, and none of them are fully plausible to me. So I do want to define naturalism as the idea that only natural laws and forces operate in the world, as opposed to supernatural, spiritual. So naturalism is the foundation of modern science, but the form that it takes is methodological naturalism. It's the philosophy of acquiring knowledge. It doesn't mean that science says that that is the ultimate reality. It just says that this is how we go from assuming that there are gods creating lightning and thunder and earthquakes and so forth, to actually studying what causes things and where they come from and how they function, what processes go on in nature. So that's methodological. There's a separate type of naturalism called metaphysical, which is where you absolutely believe in naturalism and that there is nothing but the natural processes that we're aware of today. There are no supernatural or spiritual. And my picture here is the flying spaghetti monster creating Adam. This is a model which is clearly wrong. No one believes this, but a lot of people talk about the flying spaghetti monster in order to make a useful point, which is that you can believe in any deity you want, but you cannot use that to teach science and intelligent design in an evolution classroom because it's not based on anything. So the original Sistine Chapel picture, I've spent hours in that chapel enjoying the artwork on the ceilings and around the walls, is also most likely wrong. I don't think most people believe that God assumes the same form and size and nature surrounded by angels like this. But for hundreds of years, if not thousands of years, people did believe this, and this has very much been a very useful model, and it's still a useful model for, I'd say, in some way, maybe most of the people on Earth. So the opposite sort of naturalism is dualism, which is a philosophy of mind that Wikipedia talks about. It's the position that mental phenomena are in some respects non-physical, or that the mind and body are not identical. René Descartes, the guy who said, "I think, therefore I am," promoted dualism, and he imagined that inputs from your sensory organs went to something in the brain called the epiphysis, and from there it was transferred to the immaterial spirit that he believed people have. The problem being that the epiphysis is actually the pineal gland, and it doesn't really perform that function. It produces a hormone which influences consciousness and sleepiness, but it doesn't tie in any way that one can identify to a spirit. So I got a picture here that I took in Cairo a few years ago of some pyramids, and this is another model where the pharaohs believed and people around them believed that if you put the remains of a pharaoh inside one of these things with enough materials for the afterlife, that the pharaoh would survive and have the ability to rule in the afterlife and live in the style custom. So people don't really believe this today, but it's useful for thousands of years in organized society. So the kind of questions that remain are, if immaterial spirits exist, where do they come from and where do they go? These are the kind of questions a physicist would ask. How would an immaterial spirit interact with the information stored and processed in our physical brains? Would we change the laws of physics that describe the universe if we knew that these spirits existed? What would we do? If spirits can interact with matter, can matter influence spirits? So that would mean that spirits are in some ways involved with the ordinary laws of physics. Do spirits move when your body moves? Or is it everywhere at all times and not tied to your location? There are a variety of opinions among people who are spiritual about that. would it be possible for a scientific instrument to actually detect a spirit, since it can be influenced by matter and vice versa? So my bottom line is, with or without spirits, the universe is a remarkable place, filled with many mysteries that we have yet to fully comprehend, and that continue to challenge and threaten our egocentric perceptions that we and our planet and everything, we are the center of the universe, the center of everything. And so that's the challenge. And I'm now opening it up to questions and repeating the 3 lines that I made on the original flyer. So that's the talk.